Okay, this is section 2.1 for on-ramps physics. We're recording this on August 27th. For those of you who are at the assembly, this is just what we did in class, and it'll get you started. We also, after doing this short talk, we went and did the activity that's on the FET simulation, which is described as, I think, 1.11, and it is something that you can pull the PDF off of the website and take a screenshot and mark it up. I do have hard copies run off in the classroom if you want to pick them up later today, or after you watch this. All right, so 2.1, introducing the concept of displacement. There are two terms that are similar. One is distance, the other displacement. Distance is considered a scalar quantity in that it is only magnitude. It's only size. It doesn't tell you the direction. Displacement is basically distance with a direction. So it's not only the magnitude of how far you've traveled, but also what direction you've traveled. And it's really the distance you've traveled from your reference point, the place you started. And so we need to define a few of those terms in this as we go through. First of all, position. Position really can be anywhere that you assign, for example, your starting place. So if you begin a traveling somewhere, let's say you're going on a trip, your frame of reference is your starting position, and your frame of reference, let's say, is your house. And so you travel from your house to your destination. Your frame of reference is the house that you started from. That's your starting position. Your ending position is where your destination ended at. And so that defines what we're moving towards. Displacement is not only knowing how far you've traveled, but what direction did you travel in. And so since we're establishing a path of direction, then we have both a positive and a negative direction. So if you're going in that direction you established, generally we would assign that to be positive. If you're going in the opposite direction, that would be negative. So just for y'all in class here, if we start it outside my door and I say walk to the office, then that's the reference point. That's the frame of reference. The office would be the positive direction. If you then came back and walked past Mr. Gorey's room, that would be the negative direction, negative value. And so that point outside my room would be the 0 point, positive, negative. Could I say that Mr. Gorey's room is positive and the office is negative? Yes. As the experimenter, I can assign that. But one is going to be positive, the other negative. Okay, so that's what we're talking about with position and then measuring that distance for displacement. On the screen, you see the formula given there that delta x is going to be your displacement, your change in position, with x sub f and x sub y of 0 being the initial. X sub f is your final, x sub 0 is your initial, and you subtract the two to find your change in displacement, your change in position. Then they show that being calculated here in this image with the initial position being 1.5, the final position being x sub f 3.5, and you subtract the two. 3.5 minus 1.5 gives us a positive direction of 2. That's why it's important to have x sub f minus x sub 0, not. X sub naught is, if some say it that way, because now you get a positive direction. And so if we have a positive direction, a positive change in position, when we use that to calculate our velocity later on, that will give us a positive velocity. If we're moving in the positive direction, we'll have a positive velocity. If we're moving in the negative direction, we'll have a negative velocity. We still have a value that is above zero in terms of magnitude in a negative velocity, but we're going in a negative direction, okay? All right, I think, so then they distinguish it between distance. And distance, this is a common misconception. I like to focus on misconceptions because there are many in science in general and physics specifically. So if I said, as I said earlier, we set outside my room as being the 0 mark and travel to or travel to the office, we established that as the positive direction. If we then walked back to my room and then down to, let's say, the end of the hallway, my displacement would be positive or negative? I'm asking the class. It would be negative, wouldn't it? Because I went past the 0 mark. If I said it was 100 steps to the office and then 100 steps back and then 25 steps to the end of the hall, what would be my distance in terms of steps? It would be, my distance would be 100 plus another 100 plus 25. So I'd have 225 steps. That'd be my distance, because distance doesn't care about direction. My displacement would be what? Negative 25 steps. You see the difference? So distance is your total distance traveled. Doesn't matter direction. Displacement is from your starting point. Okay?